So in order to solve this problem, we have to figure out how the total phase difference changed from point A to point B. So in order to do that, we have to find the delta phi, the capital phi in A and B, and then figure out their difference. So we have to draw this graph, and this is R1 initial, and this is R1 final. This is R2 initial, and this is R2 final. So use geometry, you can figure out their length and plug it, and then calculate delta R. And then since you know wavelength, you can plug it into this equation and then calculate delta phi at both points, and then you will figure out their difference, and that will give you the how any destructive or constructive interference the person experiences.
Hey folks, I'm Nick, and today I'm going to be helping explain problem 14. So we have a setup with the two sources, and what we're going to need to do in order to find out that delta phi at the end to get a sense of what the final interferences are going to be is we need to get a sense of the delta R between them, the difference in distance between the two sources as a person is moving between points A and B. So first, in order to do that, we know that as the person is moving along the path from A to B, they're going to have a fairly linear distance from source 1, so that we know that it's simply at 2 meters given when the person is at point A, and 8 meters given when they are at point B. But in order to calculate their distance from source 2, we end up having to use the Pythagorean theorem. With this side being 3 meters and this side being 2 meters, we plug that into the Pythagorean theorem to be 3 squared plus 2 squared, or the square root of 13, which is equal to 3.6 meters, which is that distance from source 2 to point A. The exact same process between source 2 and B, where it's 3 squared plus 8 squared is equal to the square root of 73, 8.54 meters along that hypotenuse. So once we've figured that out, what we can then do is just plug those into our delta R for the initial state at A, and that's 3.6 minus 2 is equal to 1.6, so there's a difference in R of 1.6 meters with those two distances at A, and then a delta R at B of 8.54 minus 8, which is equal to a 0.54 meter difference in distance.
Hello darkness, my old friend, I've come to talk with you again.
So the next step we're gonna do is we're gonna find the difference in the difference in the phase. So according to the phase function is 2 pi times delta R divided by lambda and the plus initial difference. So in this case, because two waves are in phase, so delta little phi is gonna be 0. If we plug in the initial value for delta R, we got 1.6 divided by 0.21, which gives us 15.24 pi. And then if we do the same thing for the final state, we got 5.14 pi.
So from those calculations, we know that the range of pi was between 15.24 and 5.14. So that's seen here between these two. So between these two values, we're trying to figure out how many odd pi's we can get, which will show destructive interference. Another way you can do this is like even interferences or constructive interferences are from when pi is an even number. So by seeing the destructive interference, we say it's 15, 13, 11, 9, and 7, and that'll be 5 destructive interferences.